Hey everyone, welcome back to channel. First of all, thank you very much for the incredibly positive feedback on my previous all-in-one 1.2.2 video. I received some really great comments on both Reddit and YouTube. And honestly, that kind of feedback gives me a lot of motivation to keep making more videos like this. So thank you again. I truly appreciate the support. Today, we are diving into something I've been genuinely excited about. Microsoft's Trellis 2 for 3D generation running directly inside ComfyUI. There are quite a few 3D generation tools out there right now, but most of them are locked behind paywalls or closed platforms. For this channel, at least for now, I am much more interested in open and accessible tools. Tools we can inspect, integrate, and build real workflows around. That's why today we are looking at Trellis 2. I've been a 3D modeling and texturing artist for about 15 years, working on several blockbuster Hollywood projects within real production pipelines. So whenever AI touches the 3D space, I am not just looking at how cool it looks. I am interested in whether it actually makes sense for real-world use. In this video, we are going to take an honest look at Trellis 2, what it can do today, where it works well, and where it still needs improvement. So let's quickly talk about what Trellis 2 actually is. At a high level, Trellis 2 is a 3D generation model that creates geometry and textures together. It works in a volumetric space first, then converts that into a textured mesh. This makes it better at handling complex shapes and open surfaces than traditional mesh-only approaches. It can generate high-resolution 3D assets with textures, and it does this surprisingly fast on modern GPUs. As you increase the resolution, you get more detail, but also longer generation times. That's expected. The key thing here is this. You are not just getting geometry, you are getting a textured asset right away. Trellis 2 is also more tolerant of complex topology, but that doesn't mean the mesh is production ready, and we will talk about why that still matters. It also generates material data like base color, roughness, metallicity, and even opacity, which makes it far more useful when bringing assets into tools like Maya or Blender. One very important thing to mention here is the license. Trellis 2 is released under the MIT license, and this is a big deal. The MIT license means you are free to use it, modify it, and integrate it into your own tools and pipelines. There are no usage restrictions, no hidden clauses, no vendor lock-in. From a production point of view, this is exactly what we want. It means studios, developers, and artists can actually build on top of it without worrying about legal issues down the line. This is one of the main reasons I am interested in Trellis 2 in the first place. Now, from a production point of view, there are a few things I really care about. What makes a model good or bad for real use? Why retopology is still important, why segmentation matters, and why UVs are absolutely critical. These are the things that determine whether an AI-generated model is actually usable. After that, I will show you how I integrate Trellis 2 into a real workflow. We will send assets into Maya and Blender, and I will show you how to build a simple bridge so these models can actually live inside a production pipeline. So with that covered, let's jump into ComfyUI, set up Trellis 2, and start generating some 3D assets. Okay, let's go with Trellis. So for Trellis, first of all, I just included in my ComfyUI installer, as you guys can see, Trellis 2 add-on. I'm going to show you. So I have an option to install this ComfyUI custom node into your current installed ComfyUI, and we are going to install another super useful custom node called Geometry Pack, and then we are going to also install ComfyUI Ultra Shape. Before showing how it works, big thanks and shout out goes to Andrea, this person. Andrea created the ComfyUI wrapper for Trellis, because Trellis, if you go here, it's a standalone application, right? Written in Python, as you guys can see here. So it is not something that will work directly inside ComfyUI for sure. So someone needs to create a wrapper for this to work in ComfyUI, and Andrea made the wrapper for us. Now, I am not using this one in my installer. I forked this repo into my own GitHub, as you can see here. The reason is very simple. For my tutorials, I want to create an ecosystem that works seamlessly with my setup. So in my Linux ConfUI installer, I am using PyEnv. I showed this and what is it in my first videos. It is like a small package that I run different Python versions and manage them. So this one is using something called conf-env. It's a different virtual environment that you can use, but because it is set to use conf-env, it was giving me conflict issues and it was not working. So I forked the repo. This is also the good side of open source. If it allows, you can fork the projects in GitHub, you can contribute to them, you can fix stuff together, and you can do your own stuff, and you can fix stuff and, for example, submit them to do upstream, stuff like that. It's a very nice ecosystem. So just because I want it to work with my own Linux ConfUI installer, I just fork it. So my installer is going to download this version, which is on my GitHub. So it is very easy to install. Let's go and say install ConfUI. I am going to install and also suggest you guys to install ConfUI with Flash Attention. Why I am not using Sage Attention this time? Because Trellis 2 doesn't support Sage Attention. And we are able to use Flash Attention with Trellis. It's a nice, simple optimization boost. So why not? We are not using it. So I will go select tree. I am an Arch-based. I am on an Arch-based setup. I will select tree. Again, I will put my sudo password and it is going to ask me my ConfUI folder to install. So I am going to install, oh my God, I have lots of ConfUI installations. Let's see if I can find a name. Burche Confi Trellis 2. Okay, it is going to ask you, I have some custom nodes. Do you want to install them? I will say no for now. Permission denied. Okay, I think I put my password wrong. Let's install tree. Yes, home, Burche, Trellis 2. No, I don't want an extra model configuration. No. As you can see, it is going to create the virtual environment that we need for with the tool that I told you, PyEnv, and now we can install. It is going to download everything for us and blah blah for our setup, for what my Linux ConfUI is set to, for Torch, of course, for CUDA versions. Okay, as you guys can see, the ConfUI is installed, but we are not done yet. This is just a ConfUI installation with Flash Attention compiled automatically for us. So this is the alias that I'm going to use to start my ConfUI. As you can see, I have 15 different ConfUI installation on my system. That's why it's giving me 15. I will copy this because I'm going to need it in a moment. I will run the script again. This time, this is new. This option 7, install Trellis 2 into an existing ConfUI. So I'm going to select 7 and I'm going to give my ConfUI folder that I just installed. So it's going to be Burche, what was the name? Trellis 2. It is going to download the custom node for Trellis, custom node for geometry pack, and custom node for ultrashape. And it is also going to install some additional dependencies by activating our virtual environment, and it will install them. So it is installing also the requirements for this custom node. As you can see, it is also going to download the ultrashape model into a model folder inside our ConfUI, because this was a manual step, so I also included it. As you guys can see, we are done. ConfUI Trellis 2 installation finished for this ConfUI installation. I am inside that ConfUI installation. If I go to custom nodes, I have my geometry pack. ConfUI manager is also always getting installed with my setup. Trellis 2, ultrashape. We are done. I need to create a new tab, new shell, and I can paste this and run this. As you can see, by the way, in the beginning, it is also going to install some wheels, Linux wheels, for some of the packages, which I will tell you about what are they. These are the main libraries that Trellis is using. So I also compiled them for my Linux ConfUI installers setup, the exact version. So I am also hosting them on my Arctic Latent Hugging Face repo. And so we are installing it. Everything is installed. You can see where is it? Flash Attention. Using Flash Attention. And now I can go to ComfUI. Okay, we are inside ComfUI and I am going to install one more node. It's optional, but I like to use it when using ComfUI. It is, what was the name? Yeah, Rise Tools, because this is giving me to monitor my VRAM usage. I like to use it. Let's wait for ComfUI, confirm. The first thing I want to create is an image. Okay, and I am going to use this example. Okay, it doesn't have a background, which is nice. I am going to show you how we can remove background because we want an image that doesn't have a background to make the Trellis work better. So what I'm going to do, I am going to upscale this image because I want to give as much as more details. So I am going to use 2048 by 2038. I don't want to crop it. So this is going to be my image. Okay, it's going to be nearest exact upscale method. It's fine. And I also need my mask. We need a mask for this workflow to work. So I am going to use something called scale mask, or what was it? Resize mask. Yes, this one, resize image mask. And I want to give a scale dimension of the same dimension. I don't want to crop, and the scale method is going to be the same. This is going to be my mask. I want to invert this mask, and I want to preview this mask because I want to be sure it is working. Okay, now we are going to bring our first Trellis node, which is Trellis to get conditioning, this guy, and the default values are fine. And this is going to get my upscaled image. This is going to get my mask, and this guy is going to get my Trellis model, which is load Trellis 2 models. And we have three different resolutions for Trellis 2. One is 512 and one is 1024 and one is 1536. Of course, 1536 is going to give you the best results, but it is so much more VRAM heavy. So you can try according to your VRAM. I will go with the middle one. Attention is the backend that we are going to use. So we can use SDPA if you are not using Flash Attention. So it means it is the default PyTorch Attention, or if you are using Xformers, you can also use this. And I'm going to use Flash Attention because we installed it. And I want to keep the model in the VRAM for optimization purposes. One more thing before I forget. If you are not following me on Linux, if you are on Windows, or if you are in a Linux but not using my script, definitely use Andreas ComfUI. It is going to do everything for you automatically, and even for Windows, as far as I remember, it is downloading and installing the required wheels for Windows. So keep that in mind. So the pre-processed image, we are not doing anything with that. So we are taking from conditioning to Trellis image to shape. We are converting an image to a shape, right? So the model config also needs my model like this. And now these are the main settings that defines the shape and how it is doing the operation. Okay, so according to my test, there is two important option here that gives you the finer, better results. One is shape sampling steps, which is now 12, and one is this one, SS sampling steps. So if you mouse over it, it is going to tell you what is it. Sparse structure sampling steps, more steps, better quality, but slower. Shape sampling steps, more steps, better quality, but slower. So if you, this is just like image to video or like image to image, video to text to image, we have steps. When you increase the steps, of course, we are getting slower generation. But for my use case, I am going to use this as 50 and shade sampling as 50, and I will keep everything as it is. Now, this is going to give me something that is not like proper mesh. I will give you more information about what is a proper mesh. So I want to remesh this. So we can get the mesh from this, and we can do, it is not available here, remesh. What is it called? Yeah, geometry pack, as you can see. So this is a different custom node, which is amazing for 3D operations. And it is from the same person. And again, big thanks to Andrea for this geometry pack wrapper also. It has lots of like super nice 3D operations like merging vertices, UV unwrapping, remeshing, stuff like that. Now, this remesh, there are different kinds of remesh algorithms in 3D. And we are going to use something called QMesh. Okay, and QMesh, where is it? Is a new high performance geometry processing for PyTorch. As you can see, it is super nice because it is CUDA accelerated mesh operation. So it is using your GPU to make the remesh operation. So we are going to use this, and I am going to give this a little bit big number for target face count. So target face count is the polygon count that it is going to produce. So I am going with 1 million. Okay, and Trellis is going to generate the mesh, but it is also going to, of course, create some flying pieces of meshes. I mean, it can, but generally it creates those because I did tests. So we are going to also we are also going to clean up the mesh that we are now creating from remesh mesh. So another very useful node from geometry pack is mesh fix. So we are going to get the remesh mesh, search mesh fix. So as you can see, this has super nice operations in it. For example, remove small components. Okay, so this is where the AI model can generate like these like super tiny flying meshes around our mesh. This is something I usually saw in the results. That's why I always keep this true. So for example, fill holes, fill boundary holes in the mesh. This is a nice option to have. Refine holes. This is also very nice because we are going to have a triangulated mesh, of course. And in a triangulated mesh, the holes that it creates is generally not going to be perfect like in a normal standard polygonal topology. So this refine holes is trying to refine those holes to give you like a better quality. Okay, and I will also talk about this in a second. I will not keep this on, by the way, sorry, because this can fill some holes that I need in the model. For example, if you look at this image, okay, it can fill some holes, for example, like this, or I don't know, like this, that I don't want. That's why I turned that off. What else? Yeah, clean mesh. I will keep this on because this is removing self-intersections and degenerate faces, which is important. And then this is now going to give me a mesh, but there is no UV. I also want to create a UV. So from the repaired, repaired mesh, I will do search and unwrap. Okay, as you can see, we have unwrap from Trellis 2 itself and the geometry pack. I will use the Trellis 2 one, okay, and the default options are fine. And I want to export this mesh now. So normally Trellis is coming with this node, but this node is only sorry, this node is only giving you GLB. If you are fine with that, use it. But today I will show you the mesh inside Maya and Blender. Maya doesn't support GLB by default. You need to install some extra plugins. I don't want to deal with them. And this also have like a remesh feature inside of it, which we see here. Okay, so it has some features that these nodes have already in it. But like I said, I don't want a GLB. What I am going to do, I am going to use another node called export trimesh, again from Trellis. So I will put this to my trimesh. This is going to be, okay, file name is Trellis 2, and file format, I can export object file format, STL. This is good for 3D printing stuff. And yeah, this is a very common, very old file format for 3D meshes. And then from file paths, I am going to go to preview 3D to see my mesh if I want to. And this will go to my file path, model file. So this node will export, let's save this, let's say geo only. We are not creating texture yet. I am only showing you mesh generation because right now the nodes that I am using, they don't have the feature to export textures yet. I will show you in a different workflow. So this is going to save this file in our output folder. Okay, now let me open this like this, maybe in the side, so you guys can see also the output. Now when we run this, it is going to download some models that's needed for this workflow automatically for you. It is downloading that model. It is called Dino version 3. Now the operation is started. It is doing the sampling. Like I said, it is doing 50 steps on my machine right now. I have a 5090, so it is going to be a little bit faster for me, but 50 steps, actually, it is too much steps for this generation. So depending on your hardware, this can be a slow generation. I mean, even on my machine, it is not that crazy fast because I increase the steps a lot because I want to see something nice. The mesh generation is done. Now it is the remeshing stuff. Operation with QMesh, it is already done, and it is now doing the mesh fix. As you can see, it is going to do, I think, 10 iterations for the mesh fix, removing degenerate faces, self intersections with multiple iterations, UV unwrapping automatically, exporting the mesh, and here we are done. We have our mesh. We can see in preview, but of course I want to see this in Maya because I want to have a better understanding of what's going on. Let's open Autodesk Maya. By the way, thank you Autodesk for giving me a license for my channel, so big thanks. So if I go to my ConfUI folder and go to output and bring this guy in, here is our mesh and it is good. Like, we are going to talk about it. Just a second. Let me make this more visible. Let's scale it. Okay. Now, if they told me 3 years ago, or I don't know, 5 years ago, that we are going to create a 3D mesh from a single image, from a perspective image like this, I would say, come on, man, like, don't be delusional. From one image, we are getting this. This is crazy, okay? Now, I am talking about, again, like I mentioned in my 2.2 video, from a modern technology perspective, this is crazy. But can we use this in production? Okay, so today I am going to also talk a lot about the production side. I am seeing lots of tutorials in YouTube where people are showing these 3D generation AI models, which is fine, of course, everyone can do whatever they want. But generally what I am seeing, people who are doing these tutorials, videos, they don't know anything about production. They don't know anything about what is happening in the production side. And they keep saying, okay, this is the end. No, this is not the end, okay? It is not even near. I have an AI channel. I really like to talk only the positive things about AI because I want to implement this in my workflow, but I also want to give you the real use case. Okay, if this is going to be useful or not, or where can it be useful? What can we do with this? Stuff like that. So if you watch those other videos where they generate something and they call it out, like this is done, this is the end of 3D modeling, stuff like that. No, this is first of all, this is a super high dense mesh. Okay, and it is, of course, if I can increase the resolution and I can get better like hard edges, stuff like that, but it is using a technology called voxel. Okay, so this is voxel mesh generation. You can read all the math or like the technical side behind it in this website. So it is also creating, like I said in the beginning of the video, base color, metallic, roughness, and alpha. But because it is a voxel based generation, we will always see these weird artifacts. Okay, even if I increase the resolution. Also, I don't want to increase the resolution that much. Why would I increase the resolution all the way to, for example, 20 millions? What I'm going to do with 20 million polygons? Okay, in production, when we are doing 3D modeling, we have now, I think it's been some time, it's not that new, we have Lidar, the scan itself. So Lidar, light detection and ranging, is a sensing method that you can see, kind of an example from this image, that uses laser pulses to measure distances and create very accurate 3D maps of environments and objects. So we are using this for a very long time. When we start a project, we are receiving something like this from the scan team, Lidar team, okay? And this is great for us, for the artists, 3D modelers or texturing artists, to start with. First of all, with its current shape, Trellis 2 doesn't support segmentation, and this model, if it's not like a background asset, it is completely useless. Because if I'm going to rig this and animate this, I cannot. I need to retopology. I need to use retopology techniques to create different segmentation. But I saw there are not lots of, but there are some 3D models which are not open source that is now able to do segmentation, different parts of the mesh. So I am 100% sure it will come to this Trellis 2 or other open source models. So I am not worried about that. It is a big plus, and I am waiting for this feature to be implemented into these open source models. Now, when we receive something like this from a scan team, as a 3D modeler, we start working on it and we start modeling this and using this as a reference, and we do something called retopology. I am going to show like a very simple example in Maya. For example, every 3D modeling software has a different kind of like retopology tool. So for example, in Maya, I can enable my modeling shelf. I can make this a live mesh, which is here. Okay, now if I go to my quad draw tool, okay, I can create polygons on this mesh. Okay, so this is what we call retopology. What is the reason of doing retopology? Optimization and also getting a better looking result. So this is a hard surface object and we want to see those nice sharp edges. As you can see, we don't have them because of the pixelation, triangulation. We see these weird shading artifacts that we call. Okay, so if this asset is super close to camera, we have in production, we have something called hero assets or a background asset. So if something is super close to camera, we call it's a hero asset and it needs like super fine details. It shouldn't have like stuff like this. You cannot use a mesh like this if it's very close to camera. If it is a background asset, this mesh is going to do wonders. It's great. Like it doesn't need to be like crazy distance even. I can use this mesh even from a mid distance. Okay, but for hero shots, very close up shots, I cannot use this. I need to do retopo. Now, what is super nice about this? Now I have a way of modeling something from a very basic image to 3D than to do real fine mesh. So for example, what can be done in production? You are talking with client, let's say they want to create it's like a science fiction TV show or something like that, and they want to create something like this. Okay, but they don't have like a real prop, because a real prop in the set, creating something like this can be super expensive or super time consuming. So they are giving you the ideas, and now what AI can do, you can give them lots of images. Image generation is super fast. You can give them like hundreds of different kinds of image like, or like a prop like this in a minute. And then, for example, they can choose, okay, we like this, and I can create a 3D mesh from that, and I can make a 3D turntable. Yes, it's not going to be perfect, but then they can say, hey, this is looking very nice in 3D also. Let's go with this. So this is good. Okay, because what is generally happening right now, you have a concept, or sometimes you don't even have a concept. You start modeling stuff and you are getting lots of like revisions, lots of notes, lots of, if you fix those revisions, for example, in the image site, in the reference site, then make a super quick 3D mesh like this, like you can save lots of times. Okay, this is why I am very interested in AI. I want to implement this in my tool set that will save me time. Okay, in its current shape, this cannot replace 3D asset artists. Okay, it's period. But this is giving lots of opportunities. So now you can say, hey, for example, you just talk about LiDAR. Why don't we use LiDAR rather than this? Because LiDAR you are not going to use everywhere. Okay, so for example, you can do a LiDAR scan of a mesh, a prop like this, but again, time. So this can give me a very accurate presentation of a reference image, a concept, like I said, that's been approved by the client in a very short time. And I can start building on it, because scanning something, like if you think about like super like big projects, everything is time consuming. So this can help with that. But let's go to mesh side again. So I'm not going to, this is how we do like a basic retopology in Maya. But what I am going to show you, what I want to show you, if I delete this, now look at this mesh. Okay, like I said, it is far from perfect for sure, but it is very dense. The biggest problem in 3D for a very long time, and this is not related to AI, we still don't have a proper auto retopology. Okay, So if I want to retopologize this with some auto retopo tools, which are not like, we have them for a very long time. For a hard surface object, they are generally much better for organic shapes, but for a hard surface object like this, we don't get anything that's useful. Believe me, I am trying lots of different retopology tools. Some of them are doing something, yes, nice, but it's not perfect. So this is why manual retopology comes handy. So for example, let's say this is a hero asset and we are going to have a camera like this, okay? Now I see all the problems of this mesh. And also we are going to see lots of problems in the texture side as well. I am going to texture this with the tool itself. It is great, by the way, doing albedo, roughness, metallic map, stuff like that. But I want to show you like what is the real approach when we are doing like a hero asset, let's say this is, and what we want to see, what we want AI to create for us, okay? Now I'm going to show you something, a very basic like a modeling. If it can be trained on proper retopology, and I believe this is going to happen, then we are going to get something like super useful that we can use in production. Okay, so let's create like, I'm not going to use retopology. I will create a cube. I will bring this guy in. Let's put like this. Okay, let's make it like this. Let's scale it. Let's do this. Something like this, something like this. I mean, it doesn't need to be perfect, but let's put an edge here. Okay, very basic representation of that shape from this model. If I bring this guy here, okay, if I select all my edges, chamfer them, okay, let's increase the resolution a little bit more. Now, if I subdivide this, okay, this is what we want to see. Okay, this is a clean mesh, clean looking mesh. Like, look at this edge. Okay, it doesn't need to be perfect, of course. Maybe I want to add some damage here, but this is not about damage. This is I gave like a super sharp edges in the image, but because of the triangulation, I am having this mesh. And as I told you, this is not like maybe the finest high quality that the model is giving me right now, but whatever it can do as of now, because of the voxelization and triangulation, I would never get this result. Okay, when it creates a mesh like this, understands the hard edges by angle, because I am 100% sure it is going to do this, because we are going to look at the UVs right now, for example, and this is not about AI. We have different UV unwrapping algorithms for a very long time. We can do UV unwrapping based on angles. So for example, if you have like a hard surface mesh, you can quickly unwrap that mesh by using angles. Okay, so but when we are talking about clean mesh, we are talking about something like this. Okay, and like I said, this model is one piece right now. This can be only used as a background, but I'm pretty sure segmentation, different parts, is going to be available. Maybe not in Trellis, but I know that it's going to be available in other maybe AI 3D generation models. Now, what is also very important when you have better topology like this, now look at the UVs. Okay, this is the UVs. Okay, so it is super easy to tell you that these UVs are terrible. Okay, it has lots of small islands because it doesn't know the optimized way of handling UVs. Okay, I can UV this model with so much more lesser UV islands. UV islands means this. These are all UV islands, UV shells. So this is now giving me, and this is, by the way, this is not about AI, okay? As far as I know, maybe I am wrong, but the UV unwrapping algorithm is something that's like a library, Atlas something. So I want a proper UV unwrapping as a 3D artist for a very long time, even before the AI. I mean, we 3D modelers, we always dream about like one button you will click and it will unwrap everything. Why UV unwrapping is terrible? Because it is 2026 and we are still doing this UV unwrapping manually. And sometimes UV unwrapping can take more time than modeling whatever you model. handling. Okay, sometimes this can happen and it's a boring process. Okay, stitching edges together, making sure that everything is like in its own island properly, and you need to think about the texturing side. You can create a UV shell thinking about a material that's going to be on that shape, and you can create that UV island according to that, etc., etc. Now let's do what the automatic UV algorithm did. So for example, it understood some of the hard edges very nice. You see, this is a hard edge because of the angle. So it put a cut here. Whatever you see white, by the way, some of the info, of course, I am giving for my non-VFX friends. Some of the info that I am giving you for if my VFX friends are watching this, can be like super simple. But yeah, I want to give info for my followers who are not in the VFX industry, but who is interested in making like 3D meshes. So some of the edges, it did a nice job. Okay, for example, it did something like this in here, very unnecessary shell. Okay, I can understand why it did this because we have a detail here, but because of the triangulation, it's impossible. We will never get like a straight line, because this is not a straight line, this is a triangulated mesh. It did a very nice job in here, as you can see. But look at this like edge. It is not like completely straight. This is going to be also problematic when you are, for example, putting a material here or painting on top of it or tiling something on top of this. If you are going to put a material in this UV shell, okay, let's say this is going to be a painted metal, a red painted metal, and this shell is going to be metal. I am going to have a texture bleed. Okay, this texture is going to bleed. It's going to bleed into other material because of how it is being structured. Okay, I will never see that like super nice, clean, sharp angle. I will give an example about this. For example, it did a very nice job on the tube shape, but still it has lots of unnecessary cuts, lots of very, very flattened area, but I still have some very unnecessary shells. I don't know why. It tried to extract these extrusions, but because of the mesh, it's not the greatest. For example, because of the triangulation, probably these two edges have a different angle than this. This is why it stopped here. But I would like to have something like this in a normal way. Yeah, UVs are a disaster, I will say, but because AI is also creating the textures from the image, we are going to look at the texture, then you will say, hey, this is looking completely fine. Yes, for that use case, it is going to look fine. But again, I will show you in production why it's not going to be very fine. First of all, there is something called UDIMs in VFX that we are using, multiple UV tiles. Okay, for example, if this is a hero asset, we will never use one UV tile. Okay, it is not going to be realistic. So this is for my, again, non-VFX friends. If this is my hero asset, okay, let's say this is a hero asset, and this is like a very basic UV of a cube, of course, it's like a dice. If this is a background asset, this UV is fine. But if we are looking like this in a very close-up shot, we need to have something called multiple UVs, multiple UV tiles, UDIMs. So then what we are doing is something like this. A very basic explanation. If I lay out these, and if I go to align and snap, this range and layout, stack shells. Okay, let's say this is one. Let's go to UV shell. Let's go to transform. Let's put this to 1. And okay, I have. Okay, so very basic demonstration. Then we want something like that with a very hero asset, because now what I am doing, I am increasing the texture resolution. Okay, think about this is going to be your, let's say, 4K texture map. Now we call this texture density. It is the amount of texture data this little guy, in this case, let's say this face, is going to get, rather than all of the faces in one UV tile, which is going to be a 4K map. So we are increasing the texture resolution. Okay, now is this related to AI? Not that much, because if I get like a nice UV result, I can do the UDIM myself. I can even automate this with Python in Maya. I can get the model from AI, UVs are nice, then I can make the layout of the UDIMs by itself. But I just wanted to talk about that in this UV situation that I don't have proper UV, so even creating UDIMs from this is not realistic. Okay, like so this is probably like going to give me lots of unnecessary UDIMs. I don't want that. So this model, for example, can be super useful for games. Again, even in games, we have hero assets and background assets. But for example, rather than a VFX pipeline, if I can think about like a game pipeline, for example, Unreal is amazing right now. They have Nanite. I can get this model, turn it into a nanite, and nanite is doing crazy stuff with high resolution meshes. I can use this without losing a crazy performance FPS. So this can be, for example, used with its texture inside a game engine like Unreal. This is like more realistic to me. But even like I said, if this is a hero game asset, then we are going to get closer to this. And I'm talking about, by the way we are using it. Like we are not doing like any post-processing on it. We get the model from AI, we put it onto the game engine, or we put it onto the offline renderer. Okay, it's not going to work if it's a hero asset. This is a assets quality that can work in mid-range, background asset, completely fine. But for hero assets, no, I mean, we don't even have like a proper, for example, circular shape here because, and that circular shape, by the way, is being refined by the mesh operation I added. Otherwise, I tested it. It's not going to be that circular, I can say. Okay. But for example, why this is very nice. Okay. Like look at these details from one image. Like really, it's crazy. Look at the image here. Okay. And look at the details here. Not like 100% match for sure, but the amount of details it grabbed, like look at these like sections, empty areas. Let me open, where is it? Yeah, this is a very good technology, by the way, this library. And the FlexGem, which is this guy, another library Trellis is using. So FlexGem is a high performance GPU matrix multiplication library designed to accelerate large transform style models used in AI-based 3D pipelines. Okay, so another library it is using. Another library that it is using, I talk about that for remeshing, QMesh. Another library it is using is this NVDiffRast. NVDiffRast is a PyTorch library that provides high performance primitive operations for rasterization-based differentiable rendering and is utilized for rendering generated assets. The other one is this guy, NVDiffReg. This is developed by NVIDIA Research, and NVDiffReg uses differentiable rendering to reconstruct geometry and materials from images and implement a split sum renderer for physical based rendering, what we call PBR materials. Okay, so this is the one that's helping to create the also PBR materials like metallic. Let's go to Maya. Okay, now I think I talked too much about the negative sides of the model because I mean I am doing modeling for 15 years. Of course, I am going to talk about the bad stuff if I see the bad stuff. But I am really wanting to achieve something good with AI and something good as a UV from AI to make my time so much more like easier. So this is super nice for concepting and starting from that concept. This is saving me lots of time. I can just find an image, turn this into an AI image and start my proper mesh around it. Okay. I am also going to create like a character. Now also we are going to see it. But again, I am telling you, the result is amazing. Like from one image, getting all these details, it's mind-blowing. It is all about how we can use it or if we can use it. This can definitely be used in VFX pipeline or in game pipeline, depending on your needs or the post-processing you done to it. If we go to this now, and where is my input folder? Here, I can put this here. I can click to refresh, and we have this little guy, crocodile. So let's see what we are going to get with a character now. I don't know if because we also have a seed here, right? So every seed is going to give me a different result. But when I first tried this, I was shocked because the detail it added to the back of the crocodile. We don't see any details rather than this tail, and it's a small amount, right? Now let's see what it's going to create. Okay, our little guy is ready. And for example, this is a different seed. The seed that I got before was much better. It was more like in line with the concept. This is not that much. It did some crazy stuff on the back, but overall it is nice. But let's see that in Maya for sure. Output, where is it? Is it this one? No, this one. Let's hide this. Okay, like really, I am so amazed by some of the details like this, like this. I mean, this is nonsense, but like I said, with a different seed, I get something on the back, like a very nice detail before. I can try different seeds, but overall, this is an open source model, right? The quality for a technology, modern technology perspective is crazy. Like, look at all these details it added here, here. Let's see the UVs. Same. So many unnecessary shells, and I think it is expected at this stage. So if we are, for example, talking about a character like this, and of course it's going to be animated, right? If we think about the other model, okay, let's say this is a static object, okay? We have static objects and animated objects, of course, in the pipeline, in production. If this is not going to move, it's a background asset, it's perfect. But this guy is going to move, okay? If it's not like a statue. I need to retopo this 100%, okay? And again, for this one, segmentation is much more important. It has clothing, okay? Because this is going to go to rigging department and they are going to rig this. Okay, and you want the cloth, for example, a separate mesh because the cloth maybe is going to have some different deformation, stuff like that. So yeah, this needs a retopo pass 100%. If you give this, of course, to a rigging artist, they are going to curse you. So don't do that. But what I am seeing as an AI generated 3D mesh is crazy. Let's look at the image again. Okay, and I am 100% sure I can get much more of these like scale details if I increase the resolution in here, plus giving it a more polygon in the remesh process. But let's see, what is the polygon count? This is around, yeah, 1 million triangle, and the amount of detail it has is amazing, okay? Because I tried Hunyan model before when I first started Conf UI, and I was so excited how it's going to do, blah, blah. It was not like crazy bad, but if I compare Hunyan with this is like night and day. And it was just like 5 months ago or something like that. So the AI is evolving super fast. So that's why I am giving all the thing that's negative, but I am also 100% sure that those problems, in my opinion, is not going to be a problem 1 year later, because we are still in the beginning of these 3D generation models, but I am following them, even the closed source ones, and the first time I saw them versus right now, like in like a 6 months difference, it's crazy. So yeah, this is crazy. Okay, so now let's put this here, but let me give you an example of, where is it? A standard character mesh. I don't say it is the greatest topology, but why optimal resolution matters. When we do characters, creatures, stuff like that, we start as much as basic with the shapes, like this one, and then we have tools like ZBrush, Mudbox, Blender has amazing sculpting also. Then we subdivide the model and put our details into model and create maps like normal maps, displacement maps, etc. This is called base mesh. This base mesh goes to then the rigging department, and they are doing the rigging and skinning on this. For example, for skinning, your mesh needs to be as much as optimal and shouldn't be like crazy heavy, because when you increase the polygon count, all these operations are becoming more slower. If this has like a super dense cloth on top of it, making a simulation of it, it's going to take time, etc., etc. So when I'm talking today about the production usage, I always think about the hardware and what we are right now in the hardware area. Lots of the things that you see, for example, in Unreal, the real-time rendering stuff like that is crazy. I don't know if you guys saw, but I just watched a video about the latest Unreal demo or something like that. So it was like a scene with like millions of trees, and the trees, they have like actual geometry leaves on top of them with real skeleton animation. And it is nanite. So it was a missing feature in nanite. Those like vegetation stuff was like stuff like that. I think nanite was not supported before, but now it is supported, and the amount of the person is showing and the FPS he was getting is like crazy. So when I think about and talk about the optimization, I also think about like what's going to be the computation time with the recent hardware, because like the modern hardware is getting also crazy, all these like NVIDIA GPU stuff like that. So maybe in a very close, like in a very like a short time, we are also going to have like a crazy hardware that is going to be implemented in all these operations that I am telling you, like rigging, rendering, like an offline render. I'm talking about an offline renderer is going to be like so much more faster. Maybe they're not going to be a problem, but I am talking about as of now, it's a problem. We need to optimize these models, especially, for example, when we are using an offline renderer, for example, like Arnold. I can put this in Unreal Engine with Nanite. Yes, it's going to perform great. This is going to perform great with Nanite, stuff like that. So I am not only talking about Unreal side, I need to talk about my area, which is VFX. So as of now, we need to do proper retopo of these meshes, to animate them, to rig them, to properly texture them, etc., etc. But the amount of details from a one picture, I keep saying this because I am really amazed by the quality of an open source model that can generate this. Like, this is a joke. So yeah, it is crazy. Why also proper, for example, topology is important. For example, this is also like for my non-VFX followers. When, let's say I'm going to sculpt on this model, we want to have as much as evenly spaced quads in a mesh like this one, because when we subdivide this, we are going to have a higher res mesh, but our smallest face is of course going to be smaller. Our smallest polygon is going to get smaller, and then we are going to be able to add like finer details, etc. One reason is, if I plane like this, okay, let's turn off the grid. If I subdivide this guy, okay, subdivide, like even on a flat surface, I don't know if it is visible in the recording, but first of all, I am going to get like some weird shading problem in this like super dense area. Also, when I try to sculpt this, I am not going to get like a proper detail when I put my brush on this, because the brush is going to do something else in here and completely it's going to do something else here. So for example, if I delete these, let's say, okay, and I mean, this is not a good example, but this is like a Maya basic sculpting brush. So now I am going to do something like this. Oops, not this. Where is this one? Okay, let's decrease this size. Sorry, strength a little bit. Okay, this is good. I am sculpting on this. Look what is happening, that I don't have enough resolution versus I have enough resolution. That's why clean, even spaced quads, when we talk about like, oh, the topology is not good or stuff like that, when we hear about something like it has a bad topology, an example can be something like this. So when you have proper topology like this, when you sculpt this and subdivide, you are going to get so much more finer results. That's why, as of now, I am telling you again, retopology matters. Also, I was going to give another example. I want to texture this. I want to unwrap this. I don't know if it has a UV. Okay, this has UVs, but let's say I don't have UVs. Okay, I want to unwrap this. When you have proper topology, you can unwrap something so much more easier. So for example, this is an edge loop. I can cut this from here, and I can cut this maybe from here, okay? And then I can get my selection constraints, UV edge loop. So this is a tool that is going to give me an edge loop between those cuts. I can select this cut. Now I can unwrap this in a very nice way. Legs, a nice loop topology I have here. I can cut from here. I can cut from here. I can select my tool again, UV edge loop, select this guy, cut, a nice clean UVs. And I can create some very nice UV shells and I can then have the optimal amount of UV shells and do my texturing. What is also going to be a problem with a mesh like this, let's say I give an example before. I want to give an extra example about this. I said this edge is not perfect and we can have like texture bleed, okay, and it can look weird, okay, like I'm going to see some like waviness on the texture because it is how the texture borders are. It's not going to be a problem for painting, but like I said, if I want, maybe I have like a tileable texture, I want to tile in this UV shell, in this one, okay? So an example will be something like this. If I create a plane, let's add an edge loop here. Oops, okay. Yeah, I have something like this all around that mesh. Let's export selection. Let's copy this path and let's say this test. Let's open Steam. Yes, in Linux, you are able to buy a license of Substance 3D Painter, Designer, etc. and launch it. Pro tip, if it is not launching, right click, go to properties, go to compatibility, click this, force the use of specific Steam Play compatibility tool and select legacy runtime. Okay, let's run Substance Painter. New project, okay, blah, blah. Okay, I am not going to be able to paste it here. So what I'm going to do, where is my Maya folder? It's here. Copy this to my documents. Oops. Okay, this is my mesh. Let's say, again, very basic example. I want like a paint spray like this in this shell. Of course, it's not going to work because let's go to UV editor. Let's first unfold this and create a shell. Orient shells layout. File, new, and this is going to be metal. Okay, so this is what's going to happen. Okay, the imperfections. So this is why I was trying to say this cannot be a hero asset because of these like imperfections. I want like a super straight line in that hard surface model in that shell, so I can have a better UV that represents that edge, and then I can have a better texture representation. Okay, now let's go to, oh, I talk a lot. I was going to make this short, but yeah, I talk a lot, sorry. Let's quickly go to the texture workflow. So I'm going to create a blank workflow. Again, I'm going to load my image. Okay, I will use this guy as an example. I'm going to use an upscale image. Okay, I want to be as much as fast. I don't want this to be, I am doing the same thing that I do. So I don't want to put the same details again and again. That's why I am copying from the other workflow. I need an image, invert mask, and again, I need a Trellis conditioning, Trellis model config will go to here. Image is going to connect it to my resize. Mask is going to be connected to this guy. We are going to use the same model config will be here. Conditioning will be this. The only new node in this workflow is Trellis to shape to textured mesh. This guy, I can put like a default seed number. I can put this to fixed. I can keep these. These are also very important. Of course, the quality of the texture sampling is coming from this. So I will make this 50, and this model config also going to get the same config, of course, this one. I will put it like this. The conditioning is going to be coming from this, and the shape result to shape results, it is something that you can easily see. And for the texture workflow, I need to use the file format this time, GLB. That's why I will go to Blender, because like I said, Maya doesn't support GLB by default if you don't use some like third-party add-ons, which is okay, that we can just look at the Blender. So what I'm going to do, I am going to export GLB. This is another new node compared to other one. This node has, for example, I am not using an extra remesh node in this one because this has remesh already in it, and the remesh count you can put here. It has the texture resolution, maximum is 4K, which is in my opinion more than enough for an open source model like this. So this is going to be like this, and this is going to be like voxel grid to voxel grid, tri-mesh to tri-mesh, and preview 3D animation. Again, let me see. Yes, I use the same settings. This should be fine. Yeah, this is the workflow. Super easy. Let's run this bad boy. Okay, we have our model generated and textured. And again, as a modern technology perspective, this is crazy. This is amazing. And because this is generating the mesh in here first, then applying the textured mesh into the model. This guy is also doing the UV unwrapping, by the way. So that's why I didn't use UV unwrapping extra that I used in Geo only. Because this is a new generation mesh, for example, this was the detail it added for, in my previous test that I really liked. So something like this, completely AI generated this according to the image that we are feeding into. Okay, now it has problems for sure. What's happening here? But yeah, we will talk about them. But yeah, super nice. Let's open Blender. Let's go to my output folder and we have the GLB here. Drag and drop, import, frame it, go to shading mode, and voila. We have a very nice looking 3D mesh with very nice textures. Problems. So first thing first, let's go to shading. Let's give us some room like this. Let's click this. So Trellis is generating albedo, which is this guy, metallic and roughness map, which is this guy. It packs the metallic and roughness map into one image. That's why we are seeing, if you look at the image itself, you are going to see this weird result. But actually the metallic is in green channel of our texture and the roughness is in blue channel. And if you go to here, you can look at them like this. So this is red, there is nothing else, nothing in this one. But if you go to green, this is our metallic map. And this is our roughness map. Now the problems is this textures it generated that it claims PBR materials are completely wrong. Why? First of all, the albedo, which is this guy, base color. Just a second. So first of all, base color. Albedo map is the base color texture using physically based rendering, what we call PBR, that defines the pure color of a surface, but without lighting, shadows, reflections, or highlight. So our albedo shouldn't include these extra info. So albedo should be like a delete version of our texture, our color. And as you can see in this image, this is not a render. We are just looking at it in the viewport right now. It has highlights, it has shadows, as you can see, everything. So albedo is wrong. Let's look at another very important map, metallic map. As soon as I look at this image, it is completely wrong. A metallic map should be either, so when you define metallic, you should either use 1 or 0. 1 means it is a metallic map. 0, it is a dielectric, non-conductive, non-metal map. So whatever you are going to define in your texture that's going to be metal should be a pure white value, which is 1. Whatever is non-metallic should be a complete black. So first of all, when I look at this map has everything like super shiny, super like metallic values. So for example, in a generation like this, according to their claim, I was expecting to see this guy completely metallic. And it did something in here, which is this guy I can see, but it is even not metallic yet. So it is doing something completely wrong. And this is something generally I am seeing also in some of the tutorials or stuff like that. There is no in-between value for metallic map in PBR. Something is either metal, 1, or something is dielectric, 0. There is no 0.5 metallic. If you want to create a more rougher metallic map, your metallic map value is going to be 1, complete white. You are going to make it shiny or rougher with your roughness map. So this is like a very big misunderstanding that I see lots of times. So there is no metallic map like this. So if we look at this crocodile in this texture map, let me see if I am not missing anything. Yes, the only thing that I should see, whatever the UV shell of this guy is, should be white. If this is metal, I am assuming it's metal. And everything else should be completely black. So it's not working. Now I am going to open Substance Painter, okay? And I am going to open a sample project. Let's open previous sphere. Also, one more thing which is very important, albedo map or your albedo texture should never be pure black or pure white. Dielectrics usually max around 50 to 240 sRGB levels. So a dielectric is a non-conductive, non-metal material that does not conduct electricity and does not behave like metal when interacting with light. That's why this is very important. This is why AI-generated textures often look wrong. They are breaking the dielectric albedo limits, and I can clearly see that also in this one. I have like I didn't like check the pixel detail of them, but I can see I have like pure blacks in my albedo, and let me see, I have like yeah, I don't have like super bright, I think, values for my highlights, but still I shouldn't have my highlights like this in an albedo map. So if I want to give you an example about dielectric and metal situation, let's put this paint. Okay, this is a paint spray material which is non-metal, dielectric. If you go to metallic channel, it is pure black. This is correct. Let's say I want to add some metallic details to this texture material. Let me see. Metal brush. Let's put this. Oh my god, this is coming with a filter effect. Let me quickly go and disable activate post effects. They are terrible. So this is now a metal. Okay, if I go to metallic map, look what is happening. Everything is white because the metal channel should be 1. So if I add a black mask to this, and if I go to some smart masks, let's add some edge wear effect like this maybe. Okay, now I am revealing metal with a mask, and if I go to my metallic map, everything that is paint spray is completely black, 0 in my metallic map. Everything is metal is white. So if I want to give another example, or let's do it like this, let's go from this example. Let's give something much like this. This is roughness. Okay, so okay, I am revealing my metal like this. Okay, this is my metallic map. Okay, it is like a mask actually, but white is metal, black is non-metal. If I go to this metallic map, and if I go to, let's see, metallic channel, add a fill and put it like this, 0.5, this is not metal. Okay, PBR doesn't work like this. There is no like, oh, this is like a little bit metal. If something is metal or not metal, and we don't want to see values like this. So it can still look in the shading side like a metal, but actually you are going to have lots of problems in lighting and rendering, and they will tell you why this is not looking like metal or shiny or stuff like that. So this texture map is complete mess. So it is acting like this is like almost the entire thing is a metal, but actually it is also doing that wrong because it has lots of in-between values. Okay, and albedo has lots of shadows and highlights, which we don't want to see in PBR texturing workflow. Now I'm going to show some nice Maya Blender bridge that I created, but before doing that, if these workflows, I am not going to put them into my Patreon because these are the workflows that's already coming with the custom node itself. So you can go to, if you are using Andreas custom node, they are inside workflow. It also has remove background workflow. I didn't show it, but it is very easy. I can quickly show. If you are using something like this, you need to use this Trellis to remove background. Actually, there is a library called RemBG, remove background. Actually, it is that node, as far as I understood, that's turned into a new node. So what is this doing? You feed your image. You can set a low VRAM or not. Let's do a partial execution. It is going to download a model, you see, because it is using a model for this operation. And it is what? It didn't remove the background. It is interesting. Let's see. Did I have any version of the following? Blah, blah, blah. Let's run again. Okay, I think this node has some problems, but if you have an image like this, it is very easy. Go to Manager, Custom Nodes Manager, search for CompUI, blah, blah, RemBG, the first one, install this, select, restart, confirm, RemBG, this one. Okay, as you can see, it is literally the same one, but I don't know why it didn't work. There are so many different remove background models in AI world. Some of them are working nice, some of them are not. But for this case, I think they are fine. So yeah, I think this is working. I hope. Let's see. As you can see, it worked. So then what you can do, this will go into here. It also, of course, give you a mask output. This will go to here. This will go to here. And then if I run this, okay, as you can see, it just works. Now, just one thing I realized, this node is already giving me the right mask that I want. So I just removed invert mask because the mask you want for this Trellis workflow, model, texture, doesn't matter, should be like this. Background is black, your subject should be white. So if you have an image like this, which already is transparent, when you get the mask, it will always give you the opposite. That's why in an image that you are feeding, if you have transparency, use invert mask. Otherwise you don't have to. And yeah, we remove the background. As you can see, it's a very complex image. It has, some leaves, stuff like that. It tried its best. And this is our result. Now, I will quickly go with some Trellis to Maya or Maya to Trellis and Blender to Trellis workflow. I created some tools and they are fun to use. Let's look at them. Okay, I am going to run my CompUI instance and I am going to run my tool. Okay, we have an empty Maya scene like this. It is asking me to define a CompUI folder. So I will define my folder. I have lots of CompUI installations. Which one was it? I think it was this one. Okay, just the root folder. We have all the node properties that's defined here. Resolution, settings, remesh settings, mesh fix settings, and it is asking me to choose an image. So I can go to my input folder and select this and generate. Let's look at our UI logs. It is generating. I am not using a crazy sampling steps here. I want to be this fast and I am meshing it with a lower triangulation amount. Yeah, I should set this to lower. This is geometry only because it is Maya. I am exporting object file because it doesn't support, and done. Maya to CompUI bridge, and we bring the mesh back. I am doing some small Python operations at the end. I am taking the lowest point of the bounding box because normally it comes like this and it comes with a smaller scale. I am scaling it, taking the lowest, calculating the lowest point of the bounding box, setting my pivot to there and moving it to world origin. So for example, this is a way of using it on a pipeline. Okay, how this works, I am not going to go into details too much because that will be a crazy long video. When you make a workflow in CompUI, if you go to file, you are going to see save as, export, and you are going to see export API. This is so nice about CompUI. This is going to give you another JSON file, just like a regular CompUI workflow file, but actually it is completely different. If you export a workflow as an API, then it's an API. You can directly access it with any like programming language you want, Python, Rust, whatever. Then you can read those nodes and you can use the CompUI backend to do operations like this. Okay, now let's go to Trellis, Blender. I also created one for Trellis. As you can see, CompUI is using this IP running on my local machine. This is for everyone when you run a CompUI. This is asking me for a CompUI folder, which I am going to choose again. Okay, and for the Blender one, we also need to define our workflow file here, which is, let's see, projects, Trellis Maya, which is inside here. So I can go to this folder. Okay, so I am running these workflows, which is, in this case, this is Blender. I will use the texture one for this one. And it is asking me for an image. Let's create the Canon one. We didn't see this with textures, I think. Let's switch to shading. And I have all the options again in Blender. Generate, it is working. Oh, I should have changed the steps. Sorry, I am using so much steps. That's why it's taking time. It is creating the texture. We are creating 2K this time to make it much more faster. Exporting the GLB, finalizing the mesh, and voila. Without going to Conv UI, we just selected our image and generated our texture and models. And we are done. So it's working nice. So these tools I am not going to share right now because they are rough and they have bugs. I mean, I just saw a new bug here. It doesn't change. It selects the folder correctly, but it doesn't change here. Anyway, I will be working on these two tools more and refine them. And I want to give you guys something completely bug-free because this is super new. These two Maya and Blender Bridge tools I created. Yeah, I will share them later on my Patreon. So I highly recommend you guys to join my Patreon. And now let's go to our final section of the video, my final thoughts. And let's see what we are going to be making in the next video also. So to wrap things up, what I find really impressive is that even today, open source AI models can already create very solid 3D results. That alone is a big deal. At the same time, coming from a VFX background as a 3D artist, it is easy to see the fundamental production issues. Things like topology, clean shapes, and usable UVs. Those things still matter a lot in real pipelines. Right now, this technology is great for prototyping, creating base meshes, background assets, and even 3D printing. You can literally print almost anything you want right now. And I strongly believe these models will only get better, cleaner geometry, better UVs, and more production-ready results. I will be following Trellis 2 very closely, especially because of its MIT license, and I will keep improving my Maya to CompUI bridge as the model evolves. We already know features like video inputs and multi-reference images are coming soon, and that's going to be huge. If you enjoyed the video, please like and subscribe. It really helps with motivation and support the channel. And if you want access to the Bridge plugin I will be releasing in the future, make sure you are part of my Patreon. Thanks for watching, and I will see you in the next one.